Okay, we're going to take a look at what we have so far. So this footage is really sped up, so just bear with me a bit. These are the wave grid cells. We'll talk about them a little more later. You can see the arrows on top of them that show which direction they're actually pushing in. So this you'll see they're pushing the boat that way. It doesn't matter which way it's facing. The red cells are the ones that are currently overlapping and pushing on the ship, and as they come in and out, they will subscribe or unsubscribe themselves from the boat. So I can adjust these values over here on the side and change how many points from the data table we're pulling in. So I can adjust the number of rows, the number of columns. I can actually adjust the size of individual cells, so I can make the blocks bigger or smaller. In this case, they're really small, so you have to come down here to see them. But all those can be changed on the fly, like prior to runtime. So they pull the values from this data table, which is generated from Funwave, so it has the UV and the ETA columns. And all three of those are stored in this data structure as floats, which are just numbers with decimals. So this is a construction script for the wave tile spawner, and it keeps an array of transforms, which are spots in 3D space. And then it loops through the data table here, and it makes the square grid for those transforms. And then for each transform, it goes and it pulls those three values from the data table, and it stores them in an array. Then it loops over them by rows and then by columns. And it actually sets those transforms equal to those values plus the offset from the starting location. So the individual grid cells are just these green blocks that turn red when they overlap. So the only thing they have is a force vector. So when they begin overlapping the ship, they tell the ship to sort of keep track of them. And then when they stop overlapping the ship, they tell the ship to stop keeping track of them. So this is the base ship model. Or the base ship blueprint. So it's on tick function, which is what happens every physics frame. It only does these four things. So it has a turning function. This is the ship induced speed. So this loops over all the engines that are on the ship, and it pulls what their current forward value is. And then if we're not currently at the top speed, we apply more speed, and if we are, we just ignore them and we keep it steady. So this is the actual apply speed function. And it comes in here and it takes this force vector and it adds in, this is the environmental section, so it adds in the wind, and then it loops over all of the grid cells that we're currently overlapping, and it sort of adds their collective force values together. And then when the loop is finished, it takes all those forces, including the wind and any other environmental forces we have, and it just pushes the boat. So this is what that looks like in the headset. So I can teleport up onto the deck, and right now I have to sort of climb to get up here because the scale for this chair and stuff up here is a bit off. So this is just a debug screen that I have here that has some variables on it, including the lever angle here for the one throttle lever we have. And it shows not only the angle that the lever is tilted at, but also the engine that it's corresponding to, what percentage of its throttle it's at from 0 to 1 and from 0 to -6. So as we overlap these grid cells here, you see they'll start to turn red, and so you can see the arrow components on them are pointing in the direction that they're going to push the ship while the ship is overlapping them. So I can turn the wheel that's also on the bridge here, and I can keep track of the wheel angle in real time, and I use that to determine how quickly the ship turns based on what percentage of tilt the wheel angle is at, coupled with how quickly the ship is moving on its linear velocity. So if the ship's like not moving at all, it won't turn when you cut the wheel. So we have a reverse gear. It only goes up to 60% of the maximum forward speed, but the linear velocity is still affected here, so it's updated in real time. The linear velocity is global based, so those numbers may look positive if we're moving on the world scale, positive x direction, even though the ship itself is moving backwards. I could translate that into local if we feel like we need it, but right now this is just for debug purposes. So these grid cells should still push the ship even if I set the throttle back to 0 here, and you'll see that regardless of which way I have the ship turned, it doesn't actually care. It's going to keep pushing the ship in the direction of those arrows. So if I turn the ship so that we're like completely perpendicular to that pushing force, and I have the engine completely stopped, as we sort of bob up and down in the buoyancy here, you can see that since we still have a non-zero linear velocity, we're going to keep moving that way. So that's basically how it is. It'll slowly push us off these cells.